And we're back. All right, that was a cool talk by Tom. I hope everybody got to join the live QA on Discord. In case you guys didn't know, there is a live QA for almost every talk after we get done. And I really hope after this talk, we get less people asking us to share word list and that sort of request. So if you're watching this and you missed the talk and you want to get into your own word listing, please give this VOD a try and make sure you follow along. I think it's a really cool way that Tom uses, open source projects, and I love how he chains different tools, for different purposes, and just spits out tons of word listing. Should we get started on our next talk?
Absolutely. The next speaker coming up is no other than Inti, and he's one of the few person that has made a show and tell in each and every of the HackerOne live hacking events. And the presentations that this gentleman presents is always mind-blowing. And to be able to have this, I don't know, a concatenated version of pretty freaking awesomeness being presented from us by no other than Inti is, for me personally, mind-blowing. So if you are hyped about Inti giving his talk, let me know in the chat so there's not lazy bots hanging around. Give me some Inti in the chat, let it free. And if I get a little bit of rumble going on with that, we're gonna let the talk go. Yeah, come on, everybody, let's get Inti. Go. Yeah, here we go.
That's blowing up now.
Awesome.
Look at
That's
it.
awesome.
That's where we're going. The hype train is live and crazy.
Perfect. I think it's time to bring Inti up. You guys ready?
Let's bring Inti on.
Let's jump into it.
All right. Hello, everybody, and welcome to my talk, You've Got Pwned, Exploiting Email Systems. We only have 20 minutes together, so let's get down to business right away. Okay, so I'll start off with a quick introduction. My name is Inti, and my accent comes from Belgium. I currently work as a community manager for bug bounty platform Integrity, where I mainly get to troll on their Twitter account. So please follow us because, it makes me money. Other than that, I've been active on several other bug bounty platforms as well, where most of my time goes into live hacking events. People that know me will know that I tend to look for a very specific range of vulnerabilities, more often than not related to email systems. And today I would like to share some of these findings with you. So first, let me state why I think emails are just so interesting. They contain a lot of confidential information, from attachments to password reset links. There's just so much specification, edge cases, and integration purposes that only very few vendors tend to get it right, actually. So the fact that most of the ideas behind email are also pretty outdated doesn't really help. This, combined with the fact that almost everybody and every service uses or implements it, makes it a very interesting and often forgotten target for bug bounty hunters. So let's start with the part that we all know, the email address. At first glance, this looks pretty straightforward, right? You have the local port, which specifies the users, then you have the little @ symbol, and then you have the domain. All right, now let's take a look at the actual specifications for the local port. I think nobody is surprised you can have Latin characters, digits, and dots in there, but what about hashes, ampersand, question marks, brackets, or percentage signs? I think the way we see an email address is based on the email providers we all know, like Gmail and Hotmail, and of course they don't really allow these characters by their choice. But it's not because they don't allow these characters in their email addresses that those are not valid email addresses according to the RFC. Now, funny thing is that things will get even a little bit more funky if you start to quote the local part of an email address, because for some reason this allows you to include some more potentially dangerous characters and even emojis. Okay, so that leaves us with the domain part, which is a little bit less funky than the local part. It does allow IP addresses when encapsulated by square brackets, which will be interesting for SSRF attacks, but more on that later. Then there's also wildcards and comments. Lots of people use wildcards to recognize or tag email addresses when signing up for third-party services. But for some reason, you can also put a comment within an email address by putting it between parentheses. I don't know who made it up, but not a lot of people seem to know about it. But email servers will actually ignore these when delivering your email. So whatever junk you put in there will still arrive, actually. So that's always interesting when you're just messing around with some payloads and want something funky, you can just put it in a comment. Now that we've seen how RFC compliant email addresses can look like, let's start to construct some valid payloads we can use for security testing. Okay, I will just let the examples speak for themselves here. All of the email addresses are perfectly valid according to the RFC. Because developers usually don't expect malicious payloads in email addresses. They're often not as properly sanitized in application flows as well. I'll get to you the slides after this presentation so you can use it for your testing. There's no need to copy them now. Apart from traditional attack vectors, these email addresses can also be used to circumvent flows that require a very specific email domain, usually from the company in question. In the first example, for example, the valid email address ends with a whitelisted domain, but when passed to the email server, it gets treated as three different email addresses, one of which is valid and will get the email intended for the actual whitelisted domain. Then the next ones would work if the parser takes the first of the last occurrence of an email address, but ignores everything followed by a semicolon or a bracket. That also happens in some specific situations. Theory is all cool and stuff, but let's see how this translates to real-world scenarios. A while ago, I sent an email to my Gmail address with some basic HTML embedded in a comment, and to my surprise, the HTML actually rendered. Unfortunately, I could not escalate this XSS, and neither could the Google security team, so it kind of remains unexploitable. However, this still works for anyone wanting to try it out or maybe escalate it. Go ahead, be my guest. I personally had some more luck with other email clients, which resulted actually in multiple stored cross-site scripting issues in different email clients. So at this moment, I don't have permission to disclose these. So you'll have to take my word for it, but I can imagine the teams behind these email providers were kind of surprised that these cross-site scripting vulnerabilities were just, around for more than a decade, and nobody really tried to get that specific email address with the crazy HTML embedded inside of it. Okay, so I hear you all saying, okay, this is cool, but outside of email clients, nobody would really accept or process these email addresses. So what's your problem, Inti? Well, you're right. I mean, most normal companies, simple regex wouldn't really consider the RFC compliant email addresses with funky characters in them. But there's still some ways to have these interact with your target. And that's often a double win, as these targets won't really be prepared to actually deal with input like that. One of the places where this actually happened was GitLab, which I would like to thank for allowing me to disclose this issue during this talk. So basically, I tried to sign up with an RFC valid email address first that contained an XSS payload. But unfortunately, their validator didn't want anything to do with that, so no luck there. But then I took a step back and I noticed that they would allow anybody to create a GitLab account through a third-party identity provider, possibly with individual differences in email validation rules. So I ended up with this table, and to my surprise, 2 of 5 identity providers fully allowed RFC compliant email addresses. Note that this is not really a vulnerability with these identity providers, they're only just following the RFC. So I checked out GitHub first and signed up for GitHub with the email that GitLab initially rejected. And then I signed up with this GitHub account linked to that specific email address. And to my surprise, it worked and the email was there. GitLab, however, properly escaped the email address, so there was no XSS there. However, the difference in identity provider flows sparked my interest, so I decided to dig a little bit deeper. Every time I wanted to inject a cross-site scripting payload through an identity provider, I had to, of course, verify that email address, except for the Salesforce flow where I could just sign up with an unverified email address. I looked into the Salesforce documentation, and as it turned out, they actually specify whether the email address is verified or not in the identity response. So it's expected behavior according to the documentation. And then I started wondering whether GitLab had correctly implemented it or not. So I set a GitLab email address in Salesforce, which I obviously could not verify. Then I looked at the IDP response, and as you can see, the email verified attribute was correctly set to false. So technically, GitLab should reject it or trigger their own verification process. So after logging into GitLab, the email address actually showed up being verified. So great, now we have an email verification bypass on GitLab side. Obviously, I tried to log into existing accounts to get account takeover basically, but since these accounts were not linked to any Salesforce instance, I could not just log into their accounts using an unverified Salesforce email address. So hijacking GitLab account itself wouldn't work, but then I remembered that like GitHub, some companies would use GitLab as an identity provider, which would now indicate that the email address is actually verified. So implementations that would only consider the verified email address for authentication would be vulnerable to account takeover. So I quickly went on Google looking for GitLab SSO implementations. And as it turned out, their own discourse-based forum had one. Here's my actual GitLab forum account linked to my HackerOne email. And take this avatar as a reference in this example. If you see this, it's my valid real account. Next up, I created the second unverified GitLab account with the same email address through the Salesforce single sign-on vulnerability. So on the left-hand side, you can see my unverified GitLab account, which appears to be verified. And then on the right-hand side, you can see my valid forum account. So I just go to the forum, then I connect my fake GitLab account, and all of a sudden I'm logged into my real account. So at this moment, I could have taken over any account without user interaction, but of course, I only use my test accounts for testing. So GitLab quickly addressed the issue by updating their single sign-on flow, and they accepted it as a critical vulnerability. I also wanted to give a quick shout out to Ron Chen. He reported the email verification process earlier, but didn't escalate it to account takeover. So technically, my submission was a dupe, but we both agreed with GitLab to increase the severity of Ron's report because of the account takeover and then split the bounty equally. Okay, ladies and gentlemen, we've spent quite some time on just email addresses and we haven't really sent a single email yet. So for the next part of my talk, I'm going to discuss some bugs that actually involve sending emails instead of just relying on email addresses. Let's simplify things for a moment. When you send an email, two things can happen. The email arrives or it does not, in which case it should bounce back to the sender. Let's be optimistic and assume that our email will actually arrive. But before we dig into this, I would like to ask you not to spam bug bounty programs or run automated tests. Always ask for permission first and read the program guidelines clearly. You never know what kind of process an email can trigger on the backend. So, and if everybody starts doing it recklessly, lots of bug bounty programs will probably close down because of all the noise. So please don't. A trick you can use for avoiding spam is verifying whether an email alias exists. You can do that, for example, with a verify SMTP command or just setting the recipient. This will not really send an email, so it won't really cause any spam. However, this won't work in all situations. It really depends on the email server. There's also some services and APIs that provide these services. So if you're into recon over email, I would advise you to look at these. So I made this list of common email addresses that usually don't link to an individual. Most of them will create some kind of ticket on the backend. Others can be configured to trigger some other kind of process. Now the customer support ones come in handy to exploit things like Ticket Trick. For those of you unfamiliar with Ticket Trick, I will drop a link to the initial blog post by myself and some further work by Uranium Hacker. And then there's also the internal ticketing system misconfiguration, which was discussed in the previous virtual conference by Uranium Hacker. But the last category is absolutely my favorite, as even though they're rare, they often lead to a lot of weird stuff. So that's what I like. Just as an example, during Recon for a live hacking event, I found out that Mapbox had this test email address that would just return half a sentence to whoever sent something to it. It's not really exploitable, but it's still a fun example, I guess. It's not that the email was completely useless though. The headers can often contain some information about the kind of software they're using. In this case, this was Help Scout. So it can really help you find additional systems and sometimes even, the version of a specific system. So always try to look at the email headers. I've also seen the weirdest setups to obtain an invite for a private Slack workspace. In one case, just emailing slack@company.com would just provide you with a sign-up link. So that was an interesting one. Another surprisingly common shadow IT misconfiguration is print@company.com that would just allow employees to send stuff to the printer and it would just print it. In a red team assessment, for example, if you encounter this, you can sign up for a Google account using print@company.com, and then the printer would print out the code for you. And you'd still need a way to retrieve the printed authentication code, but it's definitely useful to get yourself a company Google account during a red team assessment. Other than that, I've seen a lot of autoresponders. Most people would then think of out-of-office replies, for example, but especially automated services have been mailing back a lot of random stuff. Usually, these systems would look at the sender domains and see if it matches the company domain. And then if it doesn't, they get a different reply, usually containing less information. So in case attacker.com emails company.com, they may not see the auto-respond intended for employees within the same company. After fiddling around with this a little bit, I noticed that some systems would look at the from header to check whether the sender is in the company domain, and then send the auto-response back to the reply to header. So if we spoof an email from the company and then add the attacker email to the reply to header, misconfigured instances may deliver the auto-response intended for employees to somebody outside of the domain. Here's just a quick example from a bug bounty target. These emails can contain links to forms, spreadsheets, or documentation. While at it, you can also try some different attacks, and something I always try is blind XSS, blind template injection, and I've also had one case where you could just mail a PHP attachment to some ticketing service, and it would get uploaded to the same server, and the agent would open it, and it would send me back a response, an XSS Hunter response with a screenshot of a successfully executed PHP info comment. So it's essentially blind RCE. For the last part of this session, I would like to address email bounces. You may wonder how they relate to bug bounties, but I found at least 3 cases where it turned out to be useful. As a first example, I would like to showcase a Google Drive bug I stumbled upon a few years ago. I'm sure everybody in here is familiar with this screen that pops up whenever you're trying to visit a document that you don't have access to. So if you would have pressed the Request Access button, Google would send this email request on your behalf to get access to the file. And this email contains the sharing link as well as the title of the Google Drive file. In my case, the recipient's inbox was full. Since Gmail could not deliver the email including the title and sharing link, it would bounce back to the original sender, which is me. So this is the email I got back, and as you can see, it did not only disclose the title and sharing link, but also the original owner's email address was included in the bounce. Now this was a coincidence, and it only works in extreme rare scenarios, in which case the recipient's inbox would be full. So I started to investigate new ways to deliberately invoke the bounce regardless of the status of the victim's inbox. During my research, I stumbled upon the DMARC policy standard. Now, I won't lecture you today on what all of these policies do, but in simple terms, SPF and DKIM set some rules to indicate whether the email was authorized, and then DMARC actually decides what to do with it. In our case, we wanted to have an extremely strict configuration where the DMARC policy would basically tell the recipients that they should bounce back the email to us. Okay, so basically at this point, thanks to DKIM, we can ask any email forwarder to bounce the email straight back to us. But where do we really encounter these email forwarders, and how can we apply this to a bug bounty situation? Now, the first situation is not really a bug bounty situation, but it's definitely a common one. And whenever some target gets hit by a ransomware attack, the attackers often leave some kind of masked email address for support reasons. And in some cases, this will actually just forward them to their normal inbox linked to their name, which is a dumb idea, but people still do it. And in this case, for example, it was backupdata.company.com. It's obviously a reconstruction. But then, because this forwarder would just forward it to a Gmail address, whenever we would apply the DKIM trick, we would get a bounce back with the true identity, the Gmail address of the actual attacker linked to this attack. Of course, ransomware operators don't really issue bug bounties, so I also started to look at some bug bounty programs that used email forwarders. I didn't really have to look far and wide because most platforms themselves use email aliases for their hackers. So basically you can send anyone an email just by targeting their username and it will end up in their inbox. They use it so they can basically sign up with their custom domain and be recognized more easily. Of course, we also tested the integrity forwarder and it turned out we were vulnerable. So what I did was I sent an email to intdc@integrity.me, which is our email forwarder. And then, this bounce showed up actually disclosing my private Gmail address. So we quickly fixed that and luckily, there was no abuse. So I reported this within our own platform and we fixed it by setting an alternative from header. This bug would have been worth thousands of euros in bug bounty, so I'm still kind of glad that we found it ourselves, but it was definitely a nice find. To wrap up, I would like to finish with a scenario that attributed to one of my biggest bug bounties in the past year. Lots of platforms have this multi-tenant environment, which basically means that while customers get their own isolated application and just to slap their branding on, the database and the backend and just the server are still kind of the same. They're just isolated from each other, but tenants can basically sign in on the same server. They could sign in to multiple tenants. So as an example, let's take two users, Alice and John. Both have their own isolated tenant on the same server. But John triggers a password reset on his tenant, branded, they all have the domain set up and it's linked to their own domain. So he triggers a password reset for his own tenant. And of course, this will end up with John at john.io. Okay, now John gives Alice account access to his tenant, and then he triggers a password reset for Alice. So it gets sent to her email address, alice@alice.com, which contains a password reset link, basically to reset Alice's account, which has access to all these tenants. So to both John's tenant and both Alice's tenant. Now let's imagine that John, after adding Alice, he implements a very strict DKIM, basically telling the server, okay, bounce these emails back to me. Inevitably, Alice's password reset link will bounce back to John. Now John can reset the password for Alice's account, which has access to not only his, but also her workspace. And once the password is reset, John can access and take over Alice's workspace without any form of user interaction. And with this last account takeover, I'm wrapping up my talk for today. I hope you liked it and I look forward to receive your feedback and questions. Thank you all for attending my presentations and thanks to the organizers for giving me the opportunity to share this with you today.